So, as we are discussing the signals and systems since long back, and we have seen so far what is a signal, how a signal can be defined, right? And what are the types of signals we have seen, the classifications of the signals, right? Okay. And in today's presentation, I would like to explain the important terminologies that are being used in these signals and systems, right? See, for example, if you consider the classifications of the signal, the first classification is that what is the first classifications of the signal? Or before going into that, let us see. Normally a signal is like this, a signal is like this, or something any shape you can call it as something like this, or some discontinuity will be there, or something like this, or something like this, something whatever the fashion you write. So these are the different fashions actually. There are different fashions, right? This is one kind of thing actually. And uh, and uh, there are other representations also, like in terms of the square wave. Let us say this is another signal, another type of signal, okay? And sometimes you can draw like this only, or sometimes like this, okay? Different fashions will be there. This is one kind of the signal, this is another kind of the signal, right? So let us let us observe that between these two, this is one thing actually, this is one kind of signal, this is the another kind of signal. If you see these two, okay, in this, for example, the signal is starting here, it is going like this, and again it is going on, it is continuously going on without any discontinuity. It is a square wave, it is called a square wave, right? It is a square wave, it is a square wave signal. This is called a square wave signal, right? This is a continuous one, there is no discontinuity at all. So please follow the topic very clearly. Therefore I am going to give you very important insight in this presentation, right? Now let us see the second one. Okay, this is something, it is having something this shape, okay? It is quite completely different to this one. It is completely different comparing with this. Let us say here you have one pulse type, this is called a small pulse, okay? Positive half of the square otherwise, or a simple pulse. And again there is no signal at all, and here starting there is no, it is starting from here only, and it is in this fashion only. Again between here to here there is a gap here, okay? There is no signal, there is no signal in this gap, right? And again it is starting from here, somewhere it is going like this, and then it is stopped here, there is no other signal, nothing but what, this is the gap actually, this is the gap here, nothing but this is called discontinuity. What is that? Discontinuity. Therefore what I want to convey is that, so in the types of signals, continuous signal as well as this is opposite to the continuous. This is called discrete signal, this is called discrete nothing but it is not continuous, it is not continuous, understand? This is called something continuous 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 signal, okay? In continuous signal there is no gap at all, there is no discontinuity, otherwise there is no discontinuity at all. Whereas the other form of the opposite to this is called as discrete. What is that? Discrete signal. Discrete signal, in discrete signal you have no continuity at all, there is no continuity, there is a gap, there is a discontinuity. This gap we can call it as a discontinuity. that is but discrete. Discontinuity is equal to discrete, right? Therefore this is what the continuous time signal, this is the discrete time signal. Let us, okay, now let us see, as we are discussing the types of classifications of the signal. If you see the first classification, that is continuous time signal. What is the first one? What is the first classification? Continuous. Continuous time signal. Continuous time signal. Continuous time signal. Okay, remember that, remember that, remember that the signal, the continuous time signal is denoted by x of t. Remember that the continuous time signal is denoted by x of t. X is the normal, the signal type or signal, whereas t is the parameter on which the signal is depends. The signal depends on time. So any continuous time signal, this is continuous time, so this t is called as, this is continuous time. Okay, this time is nothing but continuous time, right? So this x is called as the signal. This could be any type. Maybe how many signals are there? In general, we can consider the sinusoidal signal. Okay, different signals are there. Slowly, I will explain you one after another very clearly. The first is sinusoidal signal. It is something like this. This is sinusoidal signal, and then square wave signal. Just now I drawn actually. This is the square wave signal, right? And then there is a triangular wave signal like this, triangular wave signal. And the another one is a sawtooth waveform. This is something, it goes sawtooth waveform. So different waveforms will be there, different waveforms will be there, sinusoidal wave, square wave, and triangular wave, sawtooth waveform. Different waveforms are there. Okay, your x your x can be a sinusoidal signal, your x can be square wave signal, your x can be triangular wave, your x can be a sawtooth waveform, whatever it is, right? But remember that the continuous time signal is denoted by x of t. X of t. The continuous time signal is denoted by x of t. Remember that x of t. This is the input normally. Okay, so if you simply discuss about the system, if we can see the definition of a system, that will be like this. This is a small box. This is called system. This I am calling as a system. What is a system? System is a device, electronic equipment or any device which contains certain inputs, which contains certain inputs, and it will provide certain outputs. This is output. Okay, this is output. That is what a system. Simple definition of a system. System is nothing but any electronic device which contains certain inputs to, and it provides certain outputs. That is what. So remember that here my input is denoted by x of t. My input is denoted by x of t, and correspondingly my output is denoted by y of t. My output is denoted by y of t. Always remember that throughout this subject, this is the standard form of the representation of input and output. Don't confuse. X of t is the identification. Okay, it is used to represent the signal at input side or input signal. Y of t is denoted for the output, or called as response. Output also called as or response. Output or response, right? So x of t is the input, y of t is the output. So this is the system normally, is it not? Okay, so this is the input signal x of t. Now our interest is that what are the types of input signals, what are the different types of input signals. So these we have already seen in our last presentation. So there are basically five types of signals we have classified in our previous presentations. There are five classifications we have seen. Out of those, the first one is continuous time signal. What is the continuous time signal? That is what we are discussing now. Continuous time signal. What is a continuous time signal? Continuous time signal, continuous time signal is nothing but it is something like this. It is like a sinusoidal signal. Very simple example to understand like that. Let us draw a sinusoidal signal like this. This is the signal and its amplitude is denoted by x of t. So this is the signal. This is the time. X-axis is the time t, time small t. Whereas the amplitude is x. That is why it is called as x of t. So this is the positive half, this is the negative half. Okay, this is the one cycle, actually complete cycle, and the time required to complete the one cycle is called as the time period. Whereas again from here the positive half cycle, this is another half positive negative half cycle, this is the another cycle actually, again this is another time period t. And again from here this is positive half, this is the negative half, again one positive one negative combines a complete cycle, it completes a complete like that. This is what the example for a continuous time signal denoted by x of t, denoted by x of t. Therefore in general this is the graphical representation of a sinusoidal signal, graphical form. Whereas the same can be explained in terms of the mathematical expression, that is nothing but x of t. X of t is equal to some a into sine omega t, sine omega t. A is nothing but the amplitude, peak to peak amplitude. So this is the positive peak, this is the negative peak. Let us say this is capital A, amplitude or the magnitude, magnitude or amplitude. Okay, peak to peak. This is positive A, this is the minus, this is positive A minus A, or you can write peak to peak A. A is the amplitude. Sine is nothing but it is a sinusoidal nature, no? That is why it is called as a sine. Omega t, omega is the angular frequency and it is t is the time basically. This is the mathematical expression of a sinusoidal signal. X of t is equal to a sin omega t. This is the mathematical representation of a sinusoidal signal. This is the graphical representation. This is the mathematical representation in equation form, right? Equation form. So this is the continuous time signal. This is the continuous time signal, right? Right. Similarly, say for example, this is the continuous time signal. Therefore, in continuous time signal, what we will see is that we can have certain parameters. So whatever you are seeing now, this capital T, what is the T? T is the time period. This is the called as the time period. What is the time period in continuous time signal? So continuous time signal. So this is the positive half, this is the negative half. So the one positive half and one negative half, I mean, it forms a full cycle. This is called one complete cycle or one full cycle. This is called one full cycle. Similarly, this is the another full cycle, second full cycle. This is the third full cycle or third cycle you can write. Okay, so what is the time period? What is the time required to complete a full cycle? That is called T. T is the time period required for the signal to finish to complete a full cycle. Similarly, similarly like this. So T is the time period. Nothing but what? For every T, the signal will repeats. For every T, for every time period T, the signal repeats. That is, this is called a periodic signal. What is that? A periodic signal. This is another classifications of the signal. If you see, if you if you can uh, go through our previous presentation, the first type of classification is continuous time versus discrete time, and the second is the periodic signal, a periodic signal. So what is the periodic signal? From this we can define the periodic also. What is the periodic signal? Periodic signal is nothing but it is the signal for every time period the signal will repeats. For every time period t, nothing but what? T, let us say t is equal to 1 second, let us say 1 second, 1 second. So for every 1 second the same cycle will repeat. So let us say for 1 second that the cycle is, the graph is like this. For another 1 second the same exactly same graph will comes. For another 1 second the same. Nothing but what? For every 1 second, okay, the signal will repeats in the same form. That is why it is called a periodic signal, periodic signal. Whereas the opposite of to that is aperiodic signal or non-periodic signal, where The signal will not repeat. The signal will not repeat. That is called, okay, a periodic signal. Oh, okay. I hope you understood this concept, and let us finish off this presentation here, and we will see in detail very slowly, because we should go very detail, very clearly, so that you can understand the concept of this, right? So let us see its basics, or the remaining things in our subsequent presentations. Thank you. Thank you very much.